Many thanks, Stephen, and good morning, ladies and gentlemen. I've just put my own and Tracy Wiley's name on this particular presentation. That belies the fact that there are a huge number of collaborators behind the scenes, but I didn't want to necessarily tar their good reputations just in case there was anything that was a bit off beam. But I will acknowledge them later. For those that actually listened to Hugh's presentation yesterday, you'll realize that we've got a disease that's on the move. And that disease isn't actually moving at the moment. Sorry, I'll try and get my head in gear. There we go. Sorry about that. Using the wrong piece of machinery. Septoria tritici blotch in wheat is a disease that's, like I say, creeping up through New South Wales. At the Heart Field Day last year, a lot of growers coming up and saying, hey, we don't think we had a problem, but we've got low levels of this. 2016 was a perfect launch pad for this wet weather stubble-borne disease. And therefore, if 2017 turned out to be as wet or even half as wet as 2016, this may well be a disease to keep a real careful eye on. If you want to know what it looks like on the leaf, just think of Steve Markroft's presentation and say, I've got blackleg in wheat, because you've got those pycnidia, those fruiting bodies on the leaf, appearing from about midwinter onwards. Okay, so actually the fact that disease is on the move isn't one of the key messages. The key message is that this disease is going to be difficult to control. First and foremost, it's going to be difficult to control because they've already identified in Australia, in the eastern states, mutations in this pathogen that could well affect the field performance of the triazole fungicides. At the moment, we know it affects the performance in the lab. And what we're waiting to see is how the evidence builds for it affecting the performance of triazoles in the field. Secondly, there's evidence from other parts of the world that it may well affect the performance of triazoles differentially. And at the moment in Tasmania, that is exactly what we're seeing. All of that means that although I'm going to talk about fungicides, the real key aspect here is integrated disease management is the only way that we'll keep the lid on this disease. And those are all of the tools in the toolbox, not just fungicides. Having said that, GRDC recognized the importance of the disease and made funding available for a new project in the southern region, high rainfall zone, southeast South Australia, southern Victoria and Tasmania in this last year. And although it got off the ground really late, what a year to actually start. So the results I'm going to show you are the first results out of there. They firstly question whether in fact you can apply foliar fungicides too early for control of this disease. The other aspect is that at full rate we were pleasantly surprised that we got good control of the disease with most of the foliar fungicides out there up to about 30 days. And you say, well, that's all I want. If it is, then beware of after 30 days because that's when the products start to differentiate themselves. Diseases, as you would have heard from Hugh yesterday, don't turn up on their own. They turn up in tandem. And what we had, and what we've had in the high rainfall zone for a couple of seasons, is the issues with Septoria early, and then potentially the new pathotype of leaf rust late, particularly in crops of red-grained revenue. But in this project, we've had the chance to look at activity on leaf rust as well with exactly the same products. And I can report that the efficacy there does differ between products, but that we've got some good control measures. So let's first of all remind ourselves about Septoria tritici. A few key things that as agronomists might help us to better understand it and manage it. Apologies for the diagram, a little poor quality, but broadly speaking, this represents a piece of stubble. This is the fruiting body or the perithecia developing within that stubble. As you go into the autumn, given the right environment of humidity and rainfall, what you'll find is that those perithecia, those fruiting bodies, if you had Septoria in your wheat crop last year, will give rise to the first phase of infection. That first phase is actually airborne, and those spores can travel long distances. If you try and pin down a pathologist on how far they'll go, ask the question, how far do those spores go? And usually you might get a response such as, it depends how hard the wind's blowing. In other words, it's not always easy to tell, but these are spores that will travel long distances and mean that in a region, it could be described as a social disease. When you start to see infection in your new wheat crop, it takes the form of those lesions with the black pycnidia in. Very easy to identify. And you'll see that from about June, July onwards. Now here is a key difference, because from this point on, the disease is rain splashed up the canopy. And that second phase of infection is a conidial stage that as you get windy and wet weather, you get that distribution up the canopy. But what's really important and different from the rust is that what you see there in early spring in terms of Septoria infection is likely to be all you get in terms of Septoria. Now that's important because with rust, you can get blow-ins all the way through the spring from different areas and different crops. So that raises some interesting questions about, could I take this disease out early? Before we look at some of those features of control though, there's one other really, really important point about the disease. And that's the fact that it's got one of the longest latent periods of any of the foliar diseases out there. So what does that mean? It basically means that spore on the leaf to when you can see those lesions develop is anything up to 6 weeks. But I think we need to be a bit smarter. We need to be talking not in terms of the latent period being about 28 days on average, but think in terms of thermal time, because that's the driver. So if you look at most scientific papers, they'll talk about 250 degrees C days. At 250 degrees C days, what that actually means is that in the spring, a wheat crop looks as if it's growing away from this disease. Why? Because it can produce leaves and they look as if they've got no infection. But if you have a spring period from stem elongation onwards that's scattered with point rainfall events, then what you'll actually find is that those leaves could be carrying infection. So think about thermal time and then think about using your knowledge of how long it takes for a leaf to emerge. Most leaves on a wheat crop are somewhere around 110 to 120 degrees C days. And what that means is that you could have two and a bit green leaves at stem elongation showing no infection at all, yet the disease be in full swing because it takes so long to develop. So you could get to flag leaf, for example, see the 2 top leaves are clean, and say, actually, I don't need to spray. But if you've had a lot of rainfall events and you've got Septoria in the base, you could well find that actually conditions have been extremely conducive. If you've got 3 or 4 green leaves, then perhaps you can make the conclusion that the conditions haven't been optimal for that disease development. So thinking about this sort of ideals of fungicides, we need to at least talk about the fact that it is important that we pull as many levers as possible. So integrated disease management, although I'm not going to talk about it, is thinking about cultivar resistance. And Hugh, quite rightly, yesterday said there isn't a lot of options. But there's a few little bright hopes, like Trojan's not too bad. Therefore, if you were going to plant something at the beginning of the May or the end of May, you might plant your more resistant cultivar into that earlier window, knowing that it's slightly more tolerant of the disease. So think about resistance and then think about sowing date, because early sowing really powers this disease. But again, emphasize the fact that stubble loading, how much infected stubble did you have last year? Did you notice it in crops? All of those will factor how much infection you're likely to get. In fact, we actually followed this up with a project led by some of the state departments looking at different amounts of infected straw. And what you can see here is that all we did was take some infected wheat straw that we knew hadn't received an early fungicide the season before. We put 2.5 ton on, half a ton on, or 0.1 of a ton on. And you can see that across these varieties within the yield loss experiment, you can see that the level of infection was reduced as we reduced the amount of infected stubble present. Now, this could be really relevant to you if you were in a wheat-on-wheat scenario. You can also then see the effect of no infected straw and then applying different levels of fungicide to carry that on. But it's the fungicides that I want to talk about principally. If this disease is present in the crop, and we know we're not going to get any more, say at the tillering stage, you could make an argument and say, why don't we apply a fungicide really early at tillering, and then we won't have any more problems with the disease. So that's one argument. What about, well, actually those leaves at tillering, they're not that important, and a lot of fungicide's going to go on the ground, so should I leave it slightly later? But it's infected, I can see the infection. So imagine that you've had your arm tied behind your back, you've got a crop of revenue in the high rainfall zone, and we do exactly that. We go, you can only spray once with a triazole. In this case, the triazole's one that's approved for wheat, but doesn't have a label rec for Septoria tritici, and it's Opus. The other is radial, which contains, ironically, Opus, and the strobilurin is oxystrobin. Okay, so I've tied your arm behind your back. You can only spray once. Triazole in the shape of Opus. This is the level of infection on the top 4 leaves assessed at ear emergence. So there's always going to be higher levels on those lower leaves, but this is the impact of actually spraying Opus at tillering, growth stage 30 just as it hits stem elongation, first node, and then what if we just delayed it until flag leaf? We know all the important leaves are out. That bloody POM, Nick Poole, said, you know, you've got to spray the top 3 leaves. But what you see is with Septoria, leaving the spray until flag leaf is too late. You notice that in this particular case, we've got no difference really showing up between Opus and radial. But growth stage 31 came through as the optimal timing. It would have been nice to have had growth stage 32 in there, because I think that may have shown similar results. But unfortunately, the 32 spray got delayed until 39, such was the spring. Question. Which of these treatments are the highest yielding? It's a trick question, so be careful how you answer. It's actually that one. Why? Because diseases don't turn up on their own. Septoria turns up early, leaf rust turns up late. And this is the influence of fungicides on Septoria. But the second half of the season developed leaf rust, and I'll come back to that. But the most important thing is that from a Septoria perspective, the first timing was too early if it was applied at tillering. And 31 represented a better start point. What about products? Is there any difference between these products in their ability to control? And like I say, please be aware that these products are approved in wheat, other than the coded ones, but they may not, in some cases, have a specific recommendation for triticide, mainly because it's been that many years since we've had a problem. Okay, this is Septoria infection on flag -1, the leaf below the flag. After 30 days, you can actually see that there are 3 products here that started to let go. Those products were an experimental triazole that we were looking at, which we've referred to as FAR F116, Tilt, and Follicure. But to all intents and purposes, that's reasonable control from the full label rates of those products. And you can see that there are other products there that combine a triazole and strobilurins that are doing extremely well. There's also some Prosaro and epoxyconazole, or Opus, that are also doing very well, even though they don't have a recommendation as yet for Septoria triticide. But I want to come back to those resistant mutations, because we know that we've got these mutations from our lab assessments of isolates taken in the field. What we don't know yet is how much they might impact on our field performance. But in Europe, they're having a huge impact. And the first part of the story is that they show up more on their curative or kickback activity. So in other words, that resistance or insensitivity manifests itself more around their ability to cure disease that's already developing in the crop. So look at the lower leaves now from this trial, but look at all 4 leaves to look at the performance of the products. And what you clearly see here is that at the Nawari site in southern Victoria, it was our ability to control the disease low down that was probably developing when the first of our 2 sprays went on that we're most failing with. Now, we know we've got isolates in these trials that are suspect. And I believe that what we're beginning to see is that a product that's been badly affected in Europe, even though some of their mutations are different, are beginning to show signs that they're not working quite as they should. Why? Because if you go over to Southeast South Australia and look at the sister trial, you had a similar thing happening on F-2. So, I think that we need to be looking at our crops and saying, gee, when I've used a product, and if you're using those perhaps cheaper triazoles, make sure that the rate's high, but be looking out for field performance that perhaps isn't up to the measure, because that could be the first signs of seeing that they're not doing so well against this disease. As I said, the project team had the great opportunity to look at Septoria and leaf rust with the same trial. So the next slide shows you the effect of those same fungicides against leaf rust. But now I'm exposing more of our database, because what I haven't told you is that we've got all those fungicides at 3 dose rates. 25% dose rate, 50% dose rate, and the full 100% dose rate. So this is the effect of those products now on leaf rust 30 days after flag. And luckily for us, it's not too confusing, because the products that I think one needs to be a little wary of, particularly with regards to rate, is propiconazole, tebuconazole, and this experimental triazole, should it make it out into the market. Notice that to keep the infection or the control above 75%, we really need to be in that 50 to 100% dose. If we start cutting our rates back too far, you can see that those 3 in particular start to break. So this is an untreated crop with 20% flag infected, then a 25% dose rate, a 50% and 100% dose rate. We're still putting the data together because we've literally only been harvesting these in the last couple of weeks. But what's really interesting is what's the combined effect of that on yield, septoria and leaf rust. And so we've just put together the data from the Nawari site, and I think there's some interesting things that show out. The first is that mixtures of 2 modes of action, the strobilurin, mixed with the triazole in products like Amistar Extra and Radial, have done particularly well, but I've been interested in this spike. Now, I don't think that any of us are going to go out and put full rates and 2 applications of full rates of Radial and Amistar Extra on unless we're really, really sure about the season. But what interests me about those spikes is that it's the first time in Australia I've ever seen really good effects from the strobe. And it's the strobilurin that's coming through strongly there, because the dose rates in Australia of the strobes tend to be lower than the European labels. And this is the first season I've ever seen it have an impact, and it may be the last. The other thing that really shows out is that those weaker products, unless you keep the rate up against diseases like Septoria and like leaf rust late, you're never going to get the kind of yield response that you can achieve with these other products. But given those higher rates, they're still working for us in scenarios where we know we've got issues. So lastly, Mr. Chairman, I'd like to look at a different project that we've been doing that goes back to the very first years I spent in Australia. With just one slide, one of the questions that very commonly gets asked is, how many days kickback or curative activity against common diseases like stripe rust or leaf rust can I have with commonly used triazole fungicides or those newer products like Radial? And we've been working with Sydney University under the auspices of the Australian Cereal Rust Control Program at Cobbitty, looking at controlled environment experiments where we spray at different times relative to one infection point. And I'd like to share with you some of those results. Might be a little confusing to start with, but there's 3 products. They've been applied either 1 day before infection, 3 days after infection, 7 or 11 days after infection. Then we have assessed active stripe rust as being rust that's pustulating, or what we call necrotic stripe rust, where we can see the effect of the rust, but we can't see any pustules. And when you get later and later after infection, you can get more of the effects of the disease is just about to express itself, and then it gets cut. And what we found in this work with stripe rust was that a commonly used product like epoxyconazole was giving us really good control 7 days after inoculation. so a single inoculation event. But remember, that glasshouse runs at a constant 20 degrees C. Your field crops don't. So what we've tried to do is to say, well, if it's 7 days at 20 degrees, that's 140 degrees C days roughly. And what it could mean is that if you were running with average temperatures of 5 at night and 15 during the day, your average temperature might be 10 degrees C. In which case, if you looked at 140 degrees C days, those fungicides might give you more curative or kickback activity than they're giving us in the lab at 20 degrees. We've done this now for leaf rust and stem rust, and we'll be reporting on that as we go into the autumn. But I think that it's giving us some kind of strength of feeling as just how much kickback or curative activity the products will give us. And this is some work that I hope to be talking a lot more about as we go into the winter. So, huge team of people that have helped us to get these project results off the ground, and I really just want to pay tribute to their input. In particular, I come back to the fact that the decision to run with the Septoria project in 2016 was a pretty good decision, particularly if the next 3 years are dry. Yeah, thank you very much.
Thank you, Nick. 1 minute.